All right. So again, if you can turn on your videos, most of you have them off. I want to make sure that you're actually there, as opposed to just signing in and not actually participating in class. I don't know why anybody would want to do that, because it's to your benefit to actually hear the lecture. Anyway, so we're going to cover the rest of chapter 2 today. We want to mention a computer software. Now, I had originally in the syllabus mentioned SPSS, and there was another one called JMP. And I looked at both. I had downloaded both onto my computer, both of which I had used in the past, but it's been many, many years since I've used them. And I found both of them to be unsatisfactory. They were just, to me, not intuitive and kind of difficult to use, especially for a beginning student. But that's what the university had selected. I personally like a program called Stata, which is very easy to use, and it's very comprehensive. So let's just show you what the interface looks like. And I'm going to be actually using this to generate some graphs and other different types of results. And some of these graphs may show up on a test. So I just want you to be familiar with the program that I'm using. I'll just show it to you quickly. So I'm going to share the screen and show you what it looks like when you open it up. Let me see if I have it here. Doesn't look like it is there. So let me try again with sharing. Let's see if it shows up this time. Here it is. All right, so when you open up Stata, it's a very clean looking screen, and as opposed to other programs where it's very unclean, and you got, to me, if I was a new student, I'd be confused immediately and I would open it up. This one is very, very logical the way it's set up. The reason now Stata is, to me, the best computer program that's out there that's most people don't know about. To me, it's by far the best, and it's actually, if you're ever going to get it for your own, doing your own research, maybe in graduate school, whatever you end up doing, it's not that expensive. It's pretty inexpensive, and there's no requirement for you to get a new license every year. You can get a perpetual license and have it forever. But anyway, if you can see in the top here, it's a Windows type environment. You can program in here, but it's very easy to use. If I was going to generate, for example, a graph, many of these that are listed here, we're going to show them during the course. And these other programs that I was looking at, they weren't showing any of this. They were basically saying you could try to create it with some sort of program that they have, and I tried to use it. It was very hard to use. So I decided that those two software programs that the university has chosen are not very good for a beginning student, but this one is. And this one, of course, I might try to convince the math department to buy a university level license for this. I don't know if I'll be successful, but I wanted to show it to you. And basically, when we start doing graphs next week, I'm going to show you how to do it here. Now you might ask, can you get your own license? And the answer is yes. But they do have a 1 week free trial, which is of course not good enough. But if you were going to get something for a semester, like a 6-month trial, it's pretty inexpensive for that compared to what it would cost you otherwise. I believe it's like $60 or something for the semester. But again, it's not required. You don't have to get it. But if you were interested and you wanted to learn a little bit how to use it, because you may think you might use it in the future, then let me know and I'll get you started. And then you can follow along on your computer as I'm doing the creating these graphs and charts and whatever I'm creating in here. And you'll see it's very easy to use. So I just wanted to show you the interface so that you're familiar with it. And again, send me an email if you are interested in a student license for this, because to me, this is much better than the other programs the university chose. It's just be honest with you, most people are not familiar with Stata, but Stata's been around for over 40 years. It's just not as well known as the other two. All right. So anyway, I'll stop sharing this, and we'll start getting into the PowerPoints. Now, I'm going to complete chapter 2 today, which is on collecting data. And again, they reorganized chapter 2 from an earlier edition. So I've decided to teach the first 4 sections. And hold on one second. Share that. I'm going to show you today. This is the other one. Yeah. All right. So as opposed to what's shown in the syllabus, which was really developed for an earlier edition, I'm going to modify it and have 4 sections that are covered in this course. Sections 2.1 through 2.4. And 2.3 and 2.4, which I'm covering today, are on experiments. Just the very, very, very basics about it. Our entire course is done on experiments, and the statistics behind it requires an intermediate to advanced level of knowledge of statistics. So it's not appropriate to learn how to do statistical experiments in this course, because you just don't have the background. But for a future course, you may need to actually learn this. And again, don't worry about it, because if you take an introductory course, that's all that's required as an introduction to experimentation. And then when you get into the in your department, if you are going to be taking a statistics course, it'll be probably called research methods. And every department will have a different textbook and do it a little differently. So this course is a prerequisite for anything like that. All right, so let's take a look at what's in section 2.3. And there's a lot of slides in 2.3, but I'm going to go through them fairly quickly, because there's not necessary for many of the slides to know everything that's on them, but just to give you an idea of what experiments are like in terms of how they're done, and some of the terminology that you need to know. Now, this is, if I was going to test you on this chapter, the terminology is very important, the definitions. So, but they're not hard to understand, I don't think. You just have to read the book. You should read the book, go over the slides. If you want to see the video again, of course, I post all the videos. So what is an experiment? An experiment is one in which we have one or more what are called explanatory variables. These are variables that are manipulated, changed in some way. We want to observe the effect on another variable called the response variable. Okay, a simple example, if you wanted to see how well a new drug works on people, for a certain type of disease, and then you may, the explanatory variable would be the dosage that's given of that new drug, maybe as opposed to what's given now. That would be the explanatory variable. And then you want to see if the symptoms of the disease go down. Well, that the disease itself is the response variable, right? I think that makes sense, right? Explanatory versus response. So the explanatory variables are those variables that have values that are controlled by the person doing the experiment, the experimenter. And another term that they use for explanatory variables are factors. So some places talk about 2 factors or 3 factor experiments. But that's what they're referring to, explanatory variables. Response variable is a variable that's thought to be related to the explanatory variable in an experiment. It's measured as part of the experiment, but it's not controlled. Makes sense, right? You don't want to control the response variable, then you're manipulating your results. So you're making a change to the explanatory variable and then seeing what changes, if any, are made to the response variable. Now, how do you do this? Well, you create what are called treatments, okay? Treatments. Now, the word treatment sounds more appropriate for medical research, things like that, but you can use that term also for anything in the social sciences, education. Like if you have a new reading program for a school. So you have a new reading program, an old reading program. A person doing an experiment may call those treatments, all right? Even though the word sounds kind of weird to say it, in terms of a reading program, but you can understand that they're referring to combinations of the explanatory variables, all right? So that's called the experimental condition. Any combination of values for the explanatory variables, these combinations are called treatments. Now, this can get quite complicated. Again, I'm not going into, and this book certainly doesn't go into anything further than this, except for just very simple general type of examples, okay? Just to give you an idea of what these things mean. So a well-designed experiment requires more than just manipulating explanatory variables. That's the other thing. We also have to eliminate other possible explanations that could result in changes in the response variable, all right? So there's possible other variables or other things that could be influencing the response variable, and a well-designed experiment takes care of these other things so that what's left is the effect of the explanatory variable on the response variable. All right, so that's really the goal of designing an experiment, is to allow us to look at the effects of the explanatory variable on the response variable and try to eliminate the effects of any other influences. So what are these other influences? Well, sometimes they're referred to as extraneous variables. The word extraneous means outside of something, right? So outside of the theory that you're trying to do the experiment on, some other influence could be affecting your results. So we call them extraneous or outside of the what you're studying, all right? So this is a variable that's not one of the explanatory variables in the study, but is thought to affect the response variable. So how do you know about these extraneous variables? You know about them because you've studied them, all right? You know about them. So these are known variables that could influence the results of your experiment. So what does a well-designed experiment do? One of the things that you can do is do random assignment of experimental conditions to people or things, whatever is the unit of measure, the person or things that are being measured, all right? It could be people, it could be fish, whatever the units of the experiment are. You randomly assign treatments to them. And by doing so, what you're doing is you're sort of creating the condition where if you have a couple different groups that are being studied, one versus the other, that the groups are basically have within them similar a number of extraneous variables. They're similar. So when you are comparing the two groups, these extraneous variables don't play a part because they're in both groups. So random assignment sort of allows you to justify saying that sort of thing. And but in addition to random assignment, you do have a way of sometimes directly controlling these extraneous variables. And sometimes you use what's called blocking, which I'll explain what that means in a little bit. All right, so random assignment, direct control of these other variables, and blocking are some of the strategies that are used so that you can get rid of the effects of these other variables that are not part of your experiment. Sometimes you can directly control these extraneous variables. How do you do that? You keep them constant. Now, we would have to give examples of that, but it's not unnecessary for this course. You can picture that maybe another variable, you can somehow control it so that it doesn't change, all right? And then when it doesn't change, then when there's a change in the A response variable, you could say, well, it can't be the change in this extraneous variable because I've kept it fixed. It's the same, all right? So if something's the same, it's not going to create a change in the response variable, all right? So that's one way of controlling for extraneous variable, just keep it fixed. Another way of doing is this thing called blocking. And what blocking basically says is, all right, we can't keep it fixed, this extraneous variable, but what we can do is create groups based on this extraneous variable. For example, if you may think that gender, you know, and I'm being naive here, but let's just say males and females. Obviously, you can say have more groups, but let's just keep it simple: 2 groups, males and females, and we could basically say, all right, we're going to break up our experimental group into 2 groups, males and females, because we think the differences between those 2 groups could also explain the changes in the response variable. So this is one way of controlling for it, by saying, all right, we're going to run each of our treatments within each of these groups, these subgroups, males and females. And that way, we're not, within each group, there's the extraneous variable is the same, all right? All the males, same. All the females, the same. So that way we control for the effect of that extraneous variable, in that case, gender. Now, obviously, we can block on other types of variables if we're able to do that. Sometimes we see this term called confounding or confounded, depending on the way we use it in a sentence. But this is what confounding means: is if we have 2 variables, not the response variable, but we have 2 variables that could influence the response variable, but we can't distinguish one from the other in terms of which one is actually influencing the response variable, then we would say that the 2 variables are confounded in their effects on the response variable. Confounding means we can't tell the difference between those 2 possible variables in terms of their effects on the response variable. We can't tell the difference. Let me give you a silly example. Suppose you owned a store, a retail store, and you were concerned that you weren't getting enough people into the store, all right? So what did you decide to do? You decided, well, maybe it doesn't look so great inside, and you decided to hire an interior decorator to make the store kind of look better, more inviting, so people may be invited to come in. All right, so you do that, and then you listen to the interior decorator. Decorator gives you advice, and you decide to go ahead and do it. So you make the store more snazzy. At the same time that you're doing that, a couple blocks away, a new mall is opening up. All right, and it's being advertised. People are excited about it. So a couple weeks later, after the new mall opens and after your store has this new interior that's more inviting, you start getting more people into the store. Right? Now, the real question is that the result of the interior decorating, or is it the result of the new mall opening up and there's just more people around who happen to walk into your store? Well, you don't know. You really don't, unless you study it further. So that's an example where two variables are confounding each other, and we don't know whether the response variable, which is the number of people walking in the store, is changing because of either the interior decorating or whether it's because of the mall opening up. So that's an example of what's called confounding. All right, so hopefully that makes it a little clearer. All right. Okay. Any questions about that? So you can directly control an extraneous variable. All right, you can directly control it, or you can do blocking, which again we have. I gave you an example of blocking a few minutes ago. Those are 2 ways. But what if you can't do either one? Or what if there are other variables out there that could be affecting your response variable, and you just don't know anything about them. You're not aware of them. How do you get rid of those effects? Well, that's where random assignment comes in. By randomly assigning treatments to experimental groups, you take care of not only these extraneous factors, the extraneous variables that you're aware of, but also for those that you are not aware of. All right, and that's why random assignment to experimental groups is very important. And how do you do that? You do it similar to how we talked about with observational studies. Remember when we talked about creating samples, finding people who would participate in your study. What did we do? We did simple random sampling, right? And we assigned numbers to everybody in the population, and then we used some sort of computer program to select these numbers at random, and that's how we got our people in the study. Random assignment is not the same thing, but it can be done in a similar way. If we have treatments, maybe we have 20 treatments to be randomly assigned. What do? We number the people in our study. If there's 50 people or 100 people in our study, say 100 people, we would number them from 1 to 100. And again, we use a computer to randomly select the treatments that go to those people, like that. So it's the same type of idea, right? Randomly assigning. But it's not the same thing. Let me make it very clear to you. When we say random assignment, we already have the people selected for our study, and we're randomly assigning the treatments to those people. When we talk about a random sample, those are people that are acquired for our study, all right? So through something like simple random sampling or systematic sampling, whatever sampling process we're using. So you have to make sure that you understand the difference between those two things. All right, so random assignment ensures that an experiment does not systematically favor one experimental condition over the other one, and attempts to create experimental groups that are as much alike as possible, so that these other extraneous variables don't influence the effects of your experiment. All right. All right, we want to make sure, of course, that the number of subjects in your study is not too small. This is the sample of people that have come into your study. And so as long as it's not too small, we can rely on the random assignment to produce these comparable experimental groups. All right. The random assignment is necessary for a well-designed experiment. That's very important to understand. All right. So what else is another requirement? Replication. What's replication mean? It means that we don't want to just have one subject with a treatment. All right, so there's only one subject in your study that's getting one of the a new drug. All right, let's say that's one of the treatments, just one person. All right, we want to have multiple people getting that drug, so that's called replication. We want to make sure that there's more than one person in the study that's getting a particular treatment. All right, so that's what we mean by replication. All right. And blocking, again, what does that do? It creates these additional groups that we create before we assign the treatments. Before we assign the treatments, we create these blocks. It's similar to the idea in observational studies of creating stratified sampling, creating these strata, these groups. We break up the population into groups, and then we randomly select people from and do simple random sampling within each of those groups. This is similar in the sense that we're creating these groups that are subgroups of everybody in the study, and then within each of those groups or blocks, we do all of the treatments. We run all of the treatments inside each block. Okay, and the reason why we create these blocks is that it's one way of controlling for extraneous variables. Right. The other way, of course, as I said earlier, was direct control, where you're trying to keep the extraneous variables constant. Okay. All right. Again, a lot of these slides are repeating the same thing over and over again, so bear with me. So we want to avoid this confounding that occurs with extraneous variables. Sometimes it occurs. And how do we do it? Again, we do it through the random assignment. We do it through direct control, we do it through blocking. So those are the strategies to help us avoid confounding. Okay, and again, a lot of these slides are just repeating the same thing over and over again, but it can't hurt to read the same thing again. All right, now how do you do random assignment? In a similar way, you could, every subject could be assigned a number, a unique number. You put that number on a piece of paper. You put all those pieces of paper into a box. You mix them up, and then you select one at a time to be in one of the treatment groups. One at a time to be in one of the treatment groups until you fill up that treatment group. And then everybody else goes into the other treatment group. Something like that. Kind of makes sense, right? Something you would probably think of doing. Or you can use some sort of computer program where you do, again, assign each person a number, and then the computer program will select those people to be in the first treatment group, and then everybody else, again, will be in the second. All right, so that's one way that you can do it. And then they give some examples here in here about how to create a study. I guess we could do maybe look at this example quickly. So the question in this particular study was, if a person is taking notes with a pen and other people are using a keyboard, a computer keyboard to take notes, which is better in terms of recall, in terms of recalling what you were learning about? So this was done at Princeton University. They had 67 students. So 67 students were assigned to one of two groups. Okay. And then they were shown a video. I don't know if you've ever heard of TED Talks, but anyway, doesn't matter what the video was about. And and each group was being asked to take notes. One group watched the talk in a room equipped with laptops, so that were not connected to the internet, and their job was to take notes using the laptops. And the other group was given notebooks and asked to write their notes by hand. All right, and then what happened is once the talk was over and they completed their notes, they gave them some other things to do, completely unrelated, for about a half an hour. And then after that was done, they were asked to take a test on the material from the talk. Now they weren't it wasn't open book, so they had to recall. Anyway, so the two groups took the same test, and there were two types of questions. There was one basically about facts, recalling facts that were mentioned during the talk. And then there was other questions that dealt with concepts or applications, right? Not necessarily about a fact. And what they found was that in terms of facts, there was no difference, hardly any difference, no significant difference between the two groups. But interestingly, for the concept questions, they found that the group that used laptops to take notes did much worse than the group that took notes by hand, interestingly enough. So if we assume that the researcher randomly assigned the subjects to the two groups, then this study is an experiment that compares two treatments. What are the two treatments? One treatment was, and again, you have to use the word treatment kind of loosely here. One treatment was using a laptop to use notes, and the other treatment was using handwritten notes. Now, what was the response variables? There was actually two response variables here. One was how well you did on a test that was basically fact recall questions, and the other was how well you did for responses that had to do with concepts. Right. So that's an example of how an experiment is designed, and hopefully you got an idea of what the treatments are and what the responses are. All right, so if you see something like that on a test, then hopefully the first thing you'll think about, all right, is what is the explanatory variable supposed to be? What is the response variable supposed to be? Sometimes people use diagrams to highlight their experimental designs. It can get quite complicated, but here's one example. And this is an example where on the left here, the left box says experimental units or subjects. So these are the people that are being experimented on. Okay. And then there are two treatment groups. So they're randomly assigned to one of these two treatment groups, either group A, treatment group A, or treatment group B. Then for each treatment group, you're measuring the response, whatever the response variable happens to be. All right. Now, in the previous example, the treatments were what? Treatment A could have been taking notes with a computer. Treatment B could be taking notes by hand. And then you're measuring the response. What was the response? Well, how well they did in the questions, right? The various questions that were being asked. And then you compared the results from the two groups. This type of design here, I'll show you when they talk about it. Just move forward. They have several examples here, but due to time constraints, I can't show you all of them, but I'll show you this one. It's called a completely randomized design. What does that mean? That means that everyone in the study is being randomly assigned to treatment groups. Now, there doesn't have to be two treatment groups. It could be more than two. So we're keeping this as simple as possible. We're saying there's two treatment groups, and then we're measuring their responses to the treatments. This is completely randomized design where everyone in the study is being assigned like this. All right, that's what they mean by that. So just wanted to make that clear. Again, they have several examples in here, just repetitive to me. So just showing you one way of showing it with a design. And then I want to show you another case here. This one looks a little more complicated, but this is called a block design. And they use the term randomized block design. So how does that work? Well, before we actually randomly assign treatments, we break the initial group, in this case, 128 children. Now, we don't need to know everything of what's going on here, but we can basically understand the basics here. There's 128 children, and 81 are females, 47 are males, and they're breaking them up into these blocks because they think that gender may have an effect on the response variable. So the control for this, they're going to create two blocks, two groups, subgroups of the original 128 children. Now, they don't have to be the same number, right? In this case, 81 are females and 47 are males, so they can be unequal. Then what are they going to do? Within each of the groups, these blocks, within each block or group, they're going to randomly assign the treatments, right? So again, you can go back and read about this particular study. The two treatments have to say, one has to do with hand gestures, another one without hand gestures. Again, it doesn't matter the content in this case here. We're just trying to show you the general principle. That is, when we do blocking, we create the blocks first, and then within each block, we randomly assign. All right, we do the random assignment to the treatments, to each of these people. And then we do our measure of the response, in this case, some sort of test. And then we compare, just for this group, females, we want to compare these two groups, these two treatments. All right. We do the same thing for males. For the male block, we're going to randomly assign the treatments to all 47 of these males and do exactly what we did for females. We're going to have one group with one treatment condition, another group with the other treatment condition, and then we measure the responses and we compare for the male group. All right. And then we can, at the end, combine all the groups together and make an overall comparison. But by doing it this way, we control for this extraneous variable called gender ahead of time so that it doesn't affect our results. Okay? If we did a completely randomized design, like we showed you before, this step with blocks would be not there, and we would have just randomly assigned all 128 children to the two treatment groups. However, if gender was an extraneous variable, then it's possible that we would not have been able to control for it in our results And therefore, it could be that gender could have been a confounding variable. It could be that it could have produced the difference in the results. So to control for it, we created these groups called females and males ahead of time, and then we randomly assign treatments within each group. So I wanted to show you the difference between those two types of overall structures. If I ever showed you two diagrams like this, just and to ask you which one is randomized block design and which one is a completely randomized design, I hope you can be able to tell by looking at it which one is which, right? Because the randomization process, randomizing treatments, occurs after the blocks are created in the block design. You don't see this step, creating blocks, in the completely randomized design. All right, anyway, any questions about that idea? Okay. All right, so that's it for that chapter. I wanted to, again, bring out the most important features of that, not chapter, that section. And now we're going to look in section 2.4, which is a much shorter section. See how we're doing with time. So we have about a half hour left, which is fine. And if there's no questions about that, we'll go to 2.4. All right, and let's see, where are you, 2.4? See it here, so let me go back to a second here. See if I highlight it, it will show up. There it is. Let's see, shows up now. And here it is. All right. So this is just some more detail about experimental design, just some additional terminology. Now, again, this is just a very, very, very elementary introduction. Experimental design is a much more complicated subject. Just trying to give you an introduction to it, some of the basic terminology, some of the basic designs. There's only a couple designs you need to know: completely randomized design and the randomized block design. That's all you need to know at all for this. So let's take a look at these slides. I think there's only 11 of them in this section here. All right, so what is the goal of an experimental design? All right, this is something that sort of repetitive again, but let's read through it. We want to minimize the effects of extraneous sources of variability in the response variable, so that any differences in the response for various experimental conditions can be more easily assessed or understood. All right. So basically, what we're doing is we're trying to get rid of, using more colloquial language here, we're trying to get rid of other possible influences that could be affecting the results of your experiment. We want to control for them. We want to minimize them. All right, so that the explanatory variable that we want to manipulate, any changes in that, and any changes in the response variable, we can say there is a cause and effect relationship. Right? So that's important to understand. We're trying to determine a cause and effect relationship between the explanatory variable as the cause and the response variable as the effect. All right. Now, we create these experimental groups that are similar with respect to the extraneous variables that cannot be controlled either directly or through blocking. All right. So random assignment. Okay, random assignment creates treatment groups, and we're controlling for extraneous variables that can't be either controlled or directly or cannot be blocked. Or another possibility that's not mentioned here is that we're just not aware of what these other variables could be. It's possible that there are variables out there that could be influencing the results that we're not even aware of. This randomizing treatments is a way of taking care of not only extraneous variables that we are aware of, but also those that we are not aware of. Now, sometimes in an experiment, we want to create what's called a control group. That's one of our treatment groups, a control group. What's an example? Well, let's say we have a new drug that we think may help in reducing the effects of a disease. All right, and we want to have as our control group or other treatment group something that looks exactly like the pill. Let's say it's a pill that has the active ingredients, but this pill does not have the active ingredients, and it tastes exactly the same. So basically, there's no way that the person receiving that pill will know whether it's the real drug or whether it's something else that doesn't have any active ingredients. So this group that has that something else is called a control group. So the use of a control group allows the person doing the experiment to determine how the response variable behaves when the treatment is not used. Okay, so it's basically a baseline, right, for a comparison. Right, we have our group that is taking the actual drug, and then we have a group that may think they're taking the drug, but they're not. And then we want to see whether the disease decreases more in the group that's taking the drug as opposed to the group that's not taking the drug, something like that. Okay, so it's a baseline. It's something that we're comparing the actual treatment to. That's called a control group. So let's look at an example here. It says an engineer wants to know whether a gasoline additive increases fuel efficiency. Fuel efficiency is measured in miles per gallon. So more efficient car will actually have higher miles per gallon, right? That makes sense. The experiment might use a single car to eliminate car-to-car variability. All right, so this is another way of doing an experiment. We use the same subject, in this case a car, and we use a number of trials, okay, over time, all right, in which 1 gallon of gas is put into an empty tank. And the car is driven around a racetrack at a constant speed, and the distance traveled on the gallon of gas is recorded. Now, where does the randomization occur? Well, each of these trials, every time the car is being used for this, every time a gallon of gas is put in, the driver doesn't know whether the gallon of gas has the additive or does not have the additive. All right, so that's where the randomization is occurring. Each trial is being randomly assigned either a gasoline with the additive or gasoline without the additive. To determine whether the additive increases gas mileage, it would be necessary to include a control group of trials. Well, that's the one where the gasoline doesn't have the additive, right? All right. So each trial would be randomly assigned to one of those two conditions. Either a gallon of gas has the additive or a gallon of gas does not. All right. So random assignment is important. Why? Because there could be extraneous variables that could affect fuel efficiency. It could be environmental conditions, could be temperature, right? Things could change in the environment from one trial to the next. So to control for that, we randomly assign the treatments to each trial. Even the condition of the car might change slightly from one trial to another. All right. So random assignment, in this case, tends to even out the effects of the extraneous variables. So we're basically saying, all right, does the additive cause the efficiency of the car to go up, right? Does the additive do that? And that's what we're trying to determine. Now, sometimes it's good not to know whether you're receiving the treatment or a control group, all right? Now, what is a placebo in this case here? Something that doesn't have the active ingredient. Again, in the case of the example we just did, it would be the gasoline that doesn't have the additive. In the case of a drug, it would be something that looks like the drug, tastes like the drug, but it doesn't have the active ingredients of the drug, all right? So it seems like it's identical, but it doesn't have the active ingredients. So that's what's called a placebo. All right. Here they give the example of an herbal supplement. All right. rather than using a control group that didn't receive any treatment, researchers might want to include a placebo group. Now, why do you want to do that? Because there's something called the placebo effect that's described in the textbook. That means that if a person is aware that they're getting a placebo, it may be that they think that they're still going to get the effect. All right, there's some sort of psychological thing going on where they get the results even if they know they're getting the placebo. All right, this is called the placebo effect. So how do you get around the placebo effect? You randomly assign people to a treatment or placebo, and they're not aware whether they're getting the placebo or not. All right, so that means the placebo effect will be the same in both the treatment group and the placebo group. It will be the same if there's anybody who's having that effect on the responses. All right. So it says here, as long as the subjects did not know whether they were taking the herb or the placebo group would provide a better basis for comparison. All right. Determine whether there's any, whether the herbal supplement actually works or not. All right. So we're nullifying the so-called placebo effect. Now, the idea that a participant in the study is not aware what treatment they're receiving, that is called blinding. All right, they're blinded to whether they're receiving the treatment or not. You're looking at that. So if only the subjects are blinded, that's called a single blind experiment. Okay, single blind experiment. Now, sometimes if there's somebody who might be administering the treatment, and maybe it'd be better for that person not to know which treatment a person is getting. All right, so we have people, we have a bunch of pills in a container, and they're all mixed up. Some of them are the one that has the drug, and some of them are ones that are the placebo. And the person administering the drugs to the participant, maybe it's better that they don't know, because maybe their knowledge would affect how the treatments are given to the participants. So we could talk about the person who is giving the treatments. Also, we want them to be blinded too. So if both the participant and the person administering the treatment, if they're both blinded, that's called a double blind experiment, and that's the best possible type of experiment if you can arrange it. Now, blinding is not something that you can always accomplish. Okay, now you can do it with the additive in the gasoline example. Obviously, you look at gasoline, you don't know if it has additive or not. But what if you were giving a new reading program to students at a school, right? And you were comparing it to an older reading program. And that was your control group. Well, it's pretty clear, both to the participants and to the person administering the reading programs, that you can't do blinding, right? You know you're getting the new reading program. You know, both the participant, the child, and also the person administering the program, they both know. So blinding is not something that can always be accomplished, but when it can, it really does help. Okay. So single blinded means what? It means either the participant is blinded or the person administering the treatment is blinded, but not both. That's called single blind experiment. And when both are blinded, it's called double blind. And if neither one is blinded, there's no term for that. All right? Just no blinding involved in the experiment. And here are the definitions, all right? Just so that you have it on this slide here. Double blind experiment in which neither the subjects nor the individuals who measure the response know which treatment was received. Now, you may say, all right, how can that possibly be? How can it be that the person administering treatments doesn't know what the person's getting? Well, what researchers do is they hire somebody to do the treatments. They know, the researchers might know who's being assigned what, or somebody knows. knows. Let's say you assign somebody to know that. Somebody knows that how the treatments are randomly assigned, but the person who's actually administering the treatment doesn't know. Okay, and that's the important thing. And then it describes single blind, in which only one of the group, one of the either the participant or the person administering the experiment, one of those two are the ones who are blinded, but not the other. Here's some more terminology that's important to know. An experimental unit is the smallest unit to which the treatment is given. All right, so we call that an experimental unit. It doesn't have to be a person. It could be a fish. It could be something else. All right, it could be a bigger unit than you might think. But the important point is that the treatment is being applied to something, either a person or something. And that something is called an experimental unit. And you want, in an experiment, to have multiple experimental units get the same treatment. That's called replication. Okay? Now be careful. Sometimes people think replication means doing the experiment again. In other words, having somebody else repeat the experiment. That's not replication. That's just repeating the experiment. Replication is something that's happening within one experiment, where you have more than one experimental unit receiving the same treatment. Why do you do that? So there's some variability, so that you can take an average maybe of their responses. All right. So it's always good to have some variability within each treatment group. And that's why we have what's called replication. All right, so that's what we mean by replication. All right, and it says here it's very important to have replication in an experiment. And if we don't have replication, then individual differences could play a part in your results. Let's look at this example here. So suppose that children in 2 third-grade classes are available to participate in an experiment to compare 2 different methods for teaching arithmetic. It might at first seem reasonable to select one class at random to use one method and then assign the other method to the remaining class. So what would be the experimental units here? Well, the experimental units are not the students, they're the classes, right? The classroom. The classroom's getting the experiment. All right. So the randomly assigned arithmetic method is being given to a class, not to individual students. So if that's the case, you want to have more than one class of students get a particular method of teaching arithmetic, not just one class. And that's where replication comes in. So the fact that there's many students, there could be 30 students in the classroom, it doesn't mean that's replication, because the students are all getting the same teaching method. So it's not on the level of the students that the treatment is being given, it's on the level of the classroom. So we might want to have multiple classrooms receive the same teaching method. So if treatments are randomly assigned to classes, classes are the experimental units. Because only one class is assigned to each treatment, this is an experiment with no replication, even though there are many children in each class. I want you to put a star, I mean, if you print this out, I want you to put an asterisk or something next to that right there. I'm telling you that is a very possible exam question right there. All right. All right. Because I would want to make sure that you understand what replication means. Replication has to do with experimental units. How many experimental units are receiving the treatment? In this case, the experimental units are the classes, not the students, because every student in that class is getting the same treatment. So the experimental unit is the classes, and if only one class is getting, even though it has 30 students, if only one class is getting one of the arithmetic method programs, then there's no replication. All right. So multiple classrooms have to be receiving that one method for there to be replication. All right, so I'm telling you that's an important concept right there. something I could easily ask a question about. All right, and again, once again, don't confuse replication in an experimental design with replicating an experiment, the whole experiment. In other words, somebody else doing that same experiment maybe a few years later, all right, conducting a new experiment using the same design. That's not replication. That it just means that that person's running the experiment again. That's all. So the idea of replication has to do with multiple experimental units receiving the same treatment in the same experiment. Okay? And I know I'm repeating myself, but it is an important concept. So that's why I'm doing it. Okay, any questions? Now, here is an important concept I want to bring to you. Many times experiments are done with volunteers. If it's done in a university, you may have even seen it at Rowan in the past, right? In a bulletin board, there might be a request for volunteers for an experiment. Well, if you're a volunteer for an experiment, what does that mean in terms of sampling for the experiment? The idea of having a group of people, a group of participants for an experiment. What it means is that if they're volunteers, that's called a convenience sample. And therefore, we cannot generalize the results of the experiment to the general population or to the group that we are interested in. All right, that's important to remember. So even if we do the experiment perfectly, we randomize, we can directly control for extraneous variables, we do blocking, whatever that we're doing, we do it perfectly. If our participants are volunteers, we cannot generalize to a bigger population. All right, that's important. So it's important that if you want to generalize your experimental results to a bigger population, you have to use something like simple random sampling to acquire your participants. All right. If you don't do that, if you use volunteers, that's called convenience sampling, and generalization to the larger population is not possible. All right. So that is another important concept I want to bring to your attention. All right. So again, the use of volunteers in a study might seem like a great idea. It's never a good idea in terms of sampling because the idea of generalizing to the larger population is not possible. All right. Any questions about experimentation? Because that's what we talked about today, right? On Monday, we talked about sampling. Today, we talked about experimentation. That's all we're going to go into it. The rest of the course, very few examples of experiments. We might see some, but again, the statistics that underlie experiments are complicated, intermediate to advanced. You really need to have a very good background in statistics to understand it. That's why we sort of stop here. Any questions? Nothing? Okay. All right. Hopefully you've acquired your textbook by now so that you could be reading the first 2 chapters. Please, if you do get it over the week, over the next few days, make sure you catch up. What I like to do, and I'll keep the recording on for this, one of the things I may want to do is to give you an occasional quiz, which I will obviously let you know about. So since we've finished the chapter 2, and to encourage you to read these chapters and not fall behind, on Monday we will have a quiz on vocabulary and some of these basic concepts for this. All right, so you have 5 days to do this. And what will the quiz be? It will be in Canvas. I've set up quizzes like this before in Canvas, and it will be sort of like fill in the blank. Now you'll have the book, it'll be open book. Open book. If you want to print out the slides, open slides, all right? Whatever. The only thing that you cannot do is you cannot communicate with each other. You cannot communicate with anybody else, all right? If I find out that, that's bad, all right? Cheating is a big topic at Rowan right now. So if you cheat, which I don't understand why you would cheat if it's open book, but people do anyway. If you cheat, you're just hurting yourself. If I catch you, there's bad consequences. All right, Rowan is definitely not happy about that, and they may warn you, or they may suspend you, whatever. It's not worth it. So I'm making this easy. I'm giving you a heads up. Every time I will schedule a quiz, I will let you know well ahead of time. In the future, the quizzes may involve calculations as opposed to vocabulary, but this is an introduction and I want you to read it. I want you to remember some of this, especially for the final exam. So to encourage you to do that, I'm going to have this quiz. It'll be in Canvas. It'll be towards the end of the meeting on Monday. It'll be probably 20 minutes long. Typically, I have 5 questions with statements in them with fill in the blanks. So where do I get the vocabulary from? I get them directly from the textbook. All right, not hidden in footnotes or anything. These are definitions. So if you know the definitions, if you read them, you're familiar with them, and you know where to find them in the chapters, shouldn't be any problem. But most people come into the quiz thinking, I don't need to read anything, I'll just look it up. Really, really, really bad idea. Don't do that. Don't look it up. And if you read and you become familiar with the terminology and you understand what they mean in a very general sense, you should do fine in the quiz. All right, so it's 5 statements, typically 2 or 4 blanks in them. I try to figure out and basically what you're doing is completing the sentence. So, you should have, fairly decent grammar, plurals versus singulars and things like that, and how to fill in the blank. Again, some of the sentences will come straight out of the book. So don't go in thinking you could just find it. You won't. You won't finish the quiz. You'll do poorly. Do read it. Again, I'm trying to, encourage you to read the textbook. That's why I'm doing this. Now, what does this mean in terms of the grades on your course? I'm going to create a particular part of your grading called quizzes/homework. All right, it'll be a combination of the two. So what would be homework? Now, quizzes, if I give you a quiz, it'll be something where you just one shot at it, you got to get it correct or not. And with vocabulary, there's no need to give you multiple shots. But for homework, if I call it homework and I do it the same thing in Canvas, where you take it in Canvas and you write your answers, whatever. With homework, I will give you more than one chance. So it'll say, oh, incorrect, try again, and that sort of thing. All right, so I'll have those also as part of preparing you for your tests. All right, so the quizzes and the homework will prepare you for tests. But again, the homework will be more like you're going to try a problem. If you don't get it right the first time, you still have 1 or 2 more chances to get it right, that sort of thing. Okay, and then the computer will come up with another, or maybe come up with the same example. Maybe that would be better. I think I've done that with students in the past, and students don't like it when a new problem shows up as opposed to an old one, the one that you just did. So most likely, if I give you a problem to do, and if you get it wrong the first time, you'll get a chance to get it right the second time, right? Something like that. All right, and that'll be, again, I'll tell you more about the percentage of the course for homework and slash quizzes next time, but it'll be probably around 20%. All right, any questions about that? Okay. How many, well, I guess I can't do polling right now, but again, if you are having any issues getting your book, let me know. All right, this is the time to let me know. Again, this is the second week of the course, so hopefully you got your book by now. But if there's any issues, please stay behind. Let me know. There's some way of quickening the pace. Also, make sure you have your calculator by next week. All right, because we'll start using it next week. You don't need it for the quiz. We don't need it. We didn't need it this week at all. No questions? All right, so I'll stop the recording and I will see you guys on Monday. All right. And if you have any questions, of course, you can always send me an email. Please communicate with me through Canvas. Don't send me an email directly to my email address because I get like 20 or 30 emails a day. A lot of it's junk, and I may not see it. Very easy to miss it. So better to do it in Canvas because all the emails I get in Canvas are from students. All right. So I'll